Hey guys, welcome to day 14. Finally, 2 week milestone. Should I even count them? Who cares? It's this. I remember doing this on a Sunday. So it's exactly 2 weeks. I think. I don't know. I got 2 more weeks for it to be a month. So I need to keep going. Today let's keep it simple. Let's just do a little bit more Go. I think I might just stick with this Go stuff for a bit until I finish it because I want to really get that fundamental. But I still have a project going on, maybe this Friday or whenever I get the time to. But again, still programming. I still gotta still manage to I gotta balance school and stuff. You feel me? And then I also have my internship coming up. So hopefully, if I team match with a project with Go, that's just perfect because I'm prepping without even I'm already pre-prepping right now, feel me? So, hype with that. But, the grind don't stop. Some days I might do leak code, because I don't know what to code. Some days I might do my programming assignments. But, regardless of what the circumstance is, I gotta code every day, you feel me? So, let's get it. Let's do this one. So, interfaces. I actually don't know what interfaces are in Go. So, it's good to kind of get that going up. All right, so what's I gotta grab this too. Okay. So interfaces are just a collection of method signatures. A type implements an interface if it has methods that match the interface method signatures. In the following example, a shape must be able to return its area and perimeter. Both rectangle and circle fulfill that interface. So it has a interesting collection of method signatures. A type implements an interface if it has methods that match that interface method signatures. Okay. A type implements an interface. So we have the type rectangle. Okay, another shorthand here. So what makes it special here? So when a type implements an interface, it can then be used as that interface. Okay. It then can be used as that interface type. Because we're saying the input is type shape, we know that any argument must implement the area and perimeter methods. As an example, because the empty interface does not require a type to have any methods at all, every type automatically implements the empty interface as written as. Interfaces allow you to focus on what a type does rather than how it's built. what a type does rather than how it's built. They can help you write more flexible and reusable code by defining behaviors like methods that different types can share. This makes it easy to swap out or update parts of your code without changing everything else. All right, so we have the birthday message and sending report structs already have implementations of the get message method. The get message method returns a string and any type implements that can be considered a message. Okay, what is it? So if we have this birthday method message sending report, the birthday message and sending report. Already have implementations of get message. Okay. Add the get message in method as a requirement on the message interface. All right, let's do that. So we have here a get message, and what is the syntax for that? You write the method and the thing it returns, so a string. Oh, package main. And then the send message the content of the message. It should it should return the content of the message and the cost of the message. Okay, so we can return message dot get message and the cost of the message, which is the length of the message multiplied by 3. Okay, so maybe I can, instead of calling this twice, have message, or should I shrink this? And then we just return that and the length of the message. And that's of course not. Oh wait, this is. Damn it! All right. Let's just call it message. Honestly, who cares? Message. Is that good? Go test V. Awesome. Next section. Maybe we'll just do just interfaces today. How many sections are there? Oh wow, that's a lot. Yeah. Well, we'll do maybe half. We'll see. I don't want to do too long today. Interface implementations. Interfaces are implemented implicitly. A type never declares that it implements a given interface. If an interface exists and a type has that proper methods defined, then that type automatically fulfills that interface. A quick way of checking whether a struct implements an interface is to declare that a function takes an interface as an argument. If the function can take that struct as an argument, then the struct implements that interface. Okay, makes sense. We have full-time employees and contract employees. We've been tasked with a more general employee interface so that dealing with different employee types is simpler. There's more general employee interface so that dealing with different employee types is simpler. We've been tasked with making a more general employee interface so that dealing with different employee types is simpler. Making a more general employee. We've been tasked with, yep. So dealing with different employee types is simpler. Run the code. Well, let's actually copy this. Okay, so what should we do here? Run the code. And read the errors. We cannot use constructor and struct literal. Okay. Error indicated the contractor type does not fulfill the employee interface. Okay. The contractor not employee. Yep, because it doesn't have get name and get salary. Oh. Get name, get salary, get name and salary. I think it. Oh no, it doesn't have get name, and then it doesn't have get salary. So we have to implement that. Okay. Add the missing get salary method. All right. Okay. So we can go down here and yank this. So we say get salary and c dot salary. Well, that's very recursive, is it? Well, we have to hourly pay times hourly per year, I guess. If I get, yep, that's correct. So let's test that if that works. Nice. Nice. Next one. We have like 12, 15 sections. That's cool. Interfaces are implemented to a type implements Unlike in many other languages, there's no explicit declaration of intent. There's no implements keyword. Implicit interfaces decouple the definition of an interface from its implementation. You may add methods to a type and the process by unknowingly implementing various interfaces, and that's okay. Very important, or stuff like that. Right here, yeah. More. Can a type fulfill multiple interfaces? Yeah, why not? More quizzes. Yep. Let's see. Let's read it. Remember, interfaces are collections of method signatures. A type implements a interface if it has all the methods of the given interface defined on it. If a type in your code implements an area method with the same signature, then the object is said to implement the shape interface. That the object is set to implement the shape interface. Okay. So yeah, this struct implements the interface by just having that. This is a different from most other languages where you have to explicitly assign an interface type to an object. Oh, whoa. That's facts. Okay. Go uses, there is no keyword. Yeah, there's no. Kind of weird. What was the reason for this? Is it for the flexibility of, to ensure it's not really like a object-oriented programming language? Is that really the case? In the example given, the implements the blank. Yeah. In the example given, the shape or the circle type implements the shape interface. Yeah. Okay. Multiple interface. A type can implement a number of interfaces in Go. For example, the empty interface is always implemented by every type because it has no requirements. True. All right, so let's write this. Complete the required methods so that the email type implements both the expense and formatter. Okay. Well, let's see. So how could we do this? So the email struct implements. If I implement expense and format, so if I create here like the cost, right? Then I'll implement the expense here. So let's do that. So let's do. Well, what is cost? How do I define cost? If the email is not subscribed, then the cost is 5 cents for each character in the body. If it is, then the cost is 2 cents. Return the total cost. Okay. So each character, so e dot character body. So body, we could say, or we could just say first, if not e dot subscribed, then return e dot cost, not cost, e dot body, take the length of that, multiply by, right, then the cost is 5 cents for each character, so times 5, else return length of e dot body times 2. Valid. Let's do the format. Should return a string in this format. The format method should return a string in this format. If the email is not subscribed, change the part to not subscribed. Okay. The single quotes are included in the string and content in the email's body. For example, okay. Import FMT. Let's do okay. So we'll just do the same kind of logic here, right? Like yank and B. Essentially. But we'll just do, right, fmt dot sprint f. We'll say s pipe, is it pipe? If it's not subscribed, then we say not subscribed, and we say the value is e dot body, and we'll just say the same thing here. Obviously we change the to subscribed, and yeah, let's oh, failed. Nice. Not okay, spelled this wrong. Subscribe. How do you spell subscribe, bro? Oh my goodness. Spelled it right? Okay, I didn't spell it wrong. Subscribed. Is there more content here? Body? Let's see. What am I getting here? Actual. Oh god, that's true. The single quotes are included in the string and the content. Okay. So I gotta do this. Okay. We pass. Nice. Next one. Multiple interfaces. Name your interface parameters. So we have a copy. Based on the code alone, can you deduce what kinds of string you should pass into the copy function? We know that the function expects 2 strings, but what are they? File names, usernames, raw strings. For that matter, what the heck is the int that's being returned? Let's add some parameters and return the data so that it makes it more clear. Much better. We can we can see what the expectations are now. The first parameter is the source file. Are you required to name the arguments of an interface? I don't think so. If this is... I don't think so. You don't need to... Definitely easier to read, so... Name your interface parameters. Consider the following interface. Consider the following interface. This is the same stuff, right? Why would you want your readability and clarity? Yeah. Type assertions in Go. When working with interfaces in Go, every once in a while, you'll need to access underlying type of an interface file. You can cast an interface to its underlying type using a type assertion. Okay. The example shows how to safely access the radius field of S when S is an unknown type. We want to check if S is a circle in order to cast it into its underlying concrete type. We know S is an instance of shape interface, but we do not know if it's a circle. We know S is an instance of a shape interface, but we don't know if it's a circle. C is a new circle struct cast from S. OK is true if S is indeed a circle, false if it's not a circle. Okay. Implement the get expense. We gotta copy this. Okay. Let's implement the get expense function. If the function is an email, then it should return the email's to address and cost of the email. E dot cost. So what are some examples of a cost? Wait, so email is a cost. If expense is an email, then it should return the to address and the cost of the email. If this is the SMS, it should return the to phone number and its cost. Okay. If the expense is any other underlying type, just return an empty string and zeros for the cost. Okay, easy. So let's start with the first one. If e dot is a email, So wait, hold on. Let's see the syntax again. It was C. Okay, so let's call this E, I guess. Okay. Infer the type. If not okay. If not okay. Oh. If okay. Return FMT sprint. Or just I think it's fine. I return. What do I need to return? E dot to address and the cost of the email. So E dot cost. Is this wrong? To address undefined type expenses, no field. I thought it did. Maybe I shouldn't call it E instead. I should call it. What should I call it? Email. This is not E. This should just be E. And then, so do I do the same for here? I feel like it's a little redundant, but it's okay. It's a SMS. Let's call this E though, or S. SMS to be descriptive. If okay. Return email or SMS dot. What do I return? To phone number, email or SMS dot cost. Return. I want to use this. How do I use this function here? Could I do that? Could I say I? I don't know. We'll just say e.cost. We'll see what happens. Okay. Cool. Nice. Next. Type switch. Makes it easy to do several type searches in a series. Okay. Type switch is similar to a regular switch name, but the cases specify types instead of values. Oh, okay. Switch. prints the type of the variable. After submitting our last snippet of code review from our experience cover to tell us let's grab this here. But the get expense report function using a type switch. Instead of successive assertions, let's make that improvement. Implement the get expense report function using a type switch. If the expense is an email, then it should return the email such to address and the cost of the email. Okay, so we can do the switch statements like switch. What do they do? Let's call that, I guess, v e dot type case int. So we'll do case email. Is that how it works? Case email. I return email dot to address and email dot. Oh, you gotta do the, never mind. V dot v dot cost. Wow. I'm gonna do it the default, right? Default turn v dot cost. I think to phone number. Bueno. I think we're gonna finish it today. So 12 clean interfaces. Very good. This is very good. Definitely read this too. Writing clean is very, frankly, anytime you're dealing with abstractions in your code, the simple can become very complex if you're not careful. Let's go over some rules of thumb for keeping clean interfaces clean. Interface is small. If there's only a piece of device that you want to take from this lesson, make it to this. Keep interfaces small. Interfaces are meant to define the minimal behavior necessary to accurately represent an idea or concept. Here's an example for the standard HTTP package of a large interface is a good example of defining minimal behavior. Any type that satisfies the interface behaviors can be considered by the HTTP package as a file. This is convenient because the HTTP package does not need to know if we're dealing with a file on disk, a network buffer, or a simple byte. Anytime the type satisfies the interface behaviors can be because the HTTP package doesn't need to know if we're dealing with a file on disk or a network buffer or a simple byte. Very nice. Should have no knowledge of satisfying types. An interface should define what is necessary for other types to classify as a member of that. They shouldn't be aware of types that happen to satisfy the interface at a design time. For example, let's assume we're building an interface to describe the components necessary to define a car. Color and speed make perfect sense. They are methods that confine to scope a car. Is fire truck is an anti-pattern. We are forcing all cars to declare whether or not they are fire trucks. In order for this pattern to make any amount of sense, we need a whole list of possible subtypes. Is pickup, is sedan, is tank, where does it end? Instead, the developer should have relied on the native functionality of type assertion to derive the underlying type when a given instance of a car or if its sub-interface is needed. It can be defined as that and it's a car, a type car. All the methods from car as an embedded interface adds one additional require method to make the car a fire truck. Interfaces are not class, they're slimmer. Interfaces don't have constructors or deconstructors that require the data is created or destroyed. Interfaces aren't hierarchical by nature, they are syntactic to create interfaces that happen to be supersets of other interfaces. Interfaces define function statements but not underlying behavior, making an inference won't often dry up your code in regards to struct methods. For example, if 5 types satisfies the stringer interface, they need to. Okay. Further reading. Yeah, let's take a read of this. Essentially what he kind of I don't know if these are the same, basically the same. Okay. Interfaces should have few methods as possible. Few. It's okay for interfaces to be aware of types that satisfy them. No. Reduce the complement of the implementation to define essential behavior to make the. What's the reason for keeping it small? I guess complexity. Maybe this. I'm not sure actually. Yeah, minimal. Essentially this, right? Interface allow you to define methods, behavior once. Sure. Nice. I guess the last. I got C1, challenge 2, challenge 3. Okay, let's do these two and then call it a day. Oops. As text IO evolves, the method or the team decides to introduce a new feature for custom message formats. Depending on the user's preferences, messages can be sent in different formats such as plain text, markdown code, or even encrypted text. Markdown code, or even encrypted text. To officially manage this, you implement a system using interface. Formatter interface with the method format that returns a formatted string. Okay. Define structs that satisfy the formatter. Plain text, bold code. Alright, this is pretty bold. Should wrap the message in. Oh, okay. Let's do it. This is kind of what I wanted to do for the markdown stuff, but cool. So, what do I need to make? I need to make a type formatter of, that's how you spell it, formatter interface that has a behavior of what? It has a behavior of format. So format that returns a string. Wow, what? Oh wait, is it? Hold on. Yeah. And we'll make some oops. Let's make some structs. Let's do plain text, struct. Let's do two more. Oops. Let's do bold. Whoa. And then code. Okay, I don't like the way it does that. So plain text, what's they all have a message, yeah. Type string. Yep. Message. Oh, I guess this is some syntactic sugar here. String. I guess I never knew that. Oops. If I can plop this in here too. This is some nice syntactic sugar. Okay. Learned it from the formatter himself. So all these structs have to implement the formatter, right? All these types structs are formatters. Oh no, there's no declaration. I forgot. By declaring them, you just do them by making it. So let's start with the. What's first? Let's do plain text. Let's do this here. Let's do plain text. So let's create it. So func. Let's call it P of plain text, and it should basically do format. And it should take M for message. M or message of type string and return string. And then return the FMT of message. We should do the import FMT sprintf message. Oh, we don't even need it. Just return the message. No need for any of these fancy stuff. So I need to implement for bold. So I can do, I say fmt dot sprint f the message of the thing here, which is the value, or we could say s, and bold is just surrounded that, right? Do the same thing here, but this time we're doing code. This time we just need to do backticks. How does that look? Go test. Oh, we failed. Oh, I forget. It takes no parameter. Yeah. And this message comes from the the struct itself. Whoa, sorry. p.message. We should call this b instead. Call this b. Let's call this c. xc. How's that look? Does that work? Oh, still failed. Interesting. Alright. Alright. The structs must all have a message field type of string. It's a formatted string. Okay. Oh. It's this changing here. What's with submit? I don't know. Maybe I didn't comment. Maybe I didn't comment like. Oh wow. I failed the 2. What am I failing? Cannot use plain text as plain text does not implement. Oh, thought it did though. Plain text does not implement. Is that for all of them as well? None of them are implementing the format. Oh. I should do this. Why am I not Is this not how to implement? Is this a way to? Should I just get rid of this? Maybe I'm not understanding this. Type type. Nice. We pass. Okay. Maybe, yeah, I don't know why that formatted did that for me. I guess I don't really understand it. Challenge 2. Let's do this. Wow, this is a lot. Alright. Take the mango. And grab it here. And we gotta implement these. Alright. So I gotta do stuff here. Alright. So Textio. Oh shit. What's going on here? Has a system to process different types of notifications. Direct message, group message, system alerts. Each notification type is a unique way of calculating its importance score based on user interaction and content. Okay, so implement the importance method for each type message type. Okay. They should return the importance score for each. So let's do some boilerplate for that. So we're dealing with switch statement stuff here. So let's do that. So let's do switch. T for type. So we say n dot type. What should we do with the case? So case. Start with direct message. What should we do here? The importance score is based on if the message is urgent or not. Okay. If it is urgent, the importance score is 50. Otherwise, the importance score is equal to the DM's priority level. The importance score is 50, otherwise the importance score is equal to the DM's priority. Alright. So I'm just returning, so is that what am I returning? Oh, okay. What am I? Each mess. Oh, okay. I got it. Okay. This is wrong. We gotta work on that. So I gotta write the method for importance for each one. So let's start with func. Let's start with type D direct message, and this is the importance stuff here. So I should return. So if D dot urgent, I'll return if it's urgent, then return 50. Yeah, 50. Return 50. Else return D dot priority level. Wait, if it is urgent, then the importance score is 50. Otherwise, the importance score is equal to the priority level. Oh, yeah. return 50. Why can't I do this? Too many return values. What? Do I have to say this? Too many return values. Have number. Oh, I gotta return int, right? Return d dot prior level. Yep. Func for, let's do, is it group message? Yep. Oh. G for group message. Importance. Remember, it returns an int. Where the importance is based on the message priority. Is based on the message's prior level. Okay, so just return this. That. So yeah, let's return that. D. Let's go. So fd, g. Let's do another one. This should be what is this? System. S for system alert. What are we to return here? Oh, system. Okay, return 100. Process notification. For a direct message, return the sender's username and importance score. Return the sender's username and importance score. For a group message, return the group's name and the importance score. Okay. So let's do switch. We do switch here. So let's call switch. T for type. Assign that to n dot type. And do the operation, of course. So case n. What is the case n? Let's case direct message. I want you to return the user's name. So t dot user sender username and t dot importance. Case group message. I want you to return the t dot group name, t dot importance score. Let's copy this, put that here, and then just put this here. And let's call system alert. We want to return the alert code, and default is return the string score 0. Nice. Let's test it out. Very nice. All right. I think that'll be out for today. Next time we'll do some error stuff. Get to know error stuff, and then loops, slices, pointers, packaging models with chat. Here, this is pretty cool. Mutex. This is what a lot of people love about the about Go, is its concurrency stuff, right? Isn't this what it's about? Great. I'm not sure. I don't know what I'm talking about, so ignore me. But with the interfaces, we'll do errors tomorrow. All right. Thanks for watching.